Hi, everybody. Mr. Rubo here. We are talking topic 2.14, which is logarithmic function context and data modeling. So we're going to talk about modeling with logs. So you can see here some data here. This is the average salary for a church pastor across the U.S. It increases as the church size increases, but you'll notice the pattern. It starts increasing, but then it still increases, but it's gradually not increasing as much. So that shape is very logarithmic. Okay, that's basically what this whole thing says. So yeah, just like other things, we will have logarithmic patterns. Um, but some of the things that we use logarithmic models for are earthquakes, sound, acidity, and other context. So yeah, let's talk about logarithmic function models. So for a given set of data, if the input values appear to change proportionally. Oh man, I can't spell today. Proportionally, I forgot an R in there. Oh no, and now my stylus doesn't want to erase. All right, proportionally. Oh my gosh. There we go. Over equal length output values. So you'll notice sounds like an exponential, but things are switched. The input values are what's changing proportionally, and the output is equal length. Okay, that's how we know it's a log. Okay, and the general form for a log model is y equals a plus b ln of x. Okay, this model here uh, is the natural log model. It's very common, like that's the way our the TI calculators use is a plus b ln x. But you could also sometimes see it with a common log, so a plus b log of x, where a and b are constants and b is not equal to 0, because obviously if it was equal to 0, there'd be no log. Okay, so let's go ahead to this. So what we're going to do here is, and this is a very AP FRQ type question, we're given two data points, right? And they tell us, hey, it's a log equation. We're going to use a plus b ln x. And what we're going to do first is write two equations using the constants for a and b. So we're just going to plug them in for x and y. So the first point is going to be 3 equals a plus b ln of the x, which is 2. And then the second equation, same idea. Okay. This right here is, if we were solving this by hand, this would help us out. Okay. So I could solve this by hand. 100% doable to do it by hand, but we can also do a regression. Okay. So if you were doing a regression, you would go to your calculator, type it in the calculate in the stat menu, and then you'd calculate, and then there is ln regression, right? If you're using Desmos, same idea, type in the table and then do it. I'll show the long work, which is by hand, and most of the time I don't recommend it. I would just do it using the regression, but here we go. So what I'm going to do here is I'm going to take my first equation and solve it for one of my variables. So I'm going to solve the first equation for a. So I'm going to say 3 minus b ln of 2 equals a. Just subtracted that over. Okay. So now what I can do is I can substitute this in to the other equation. So I can say 7 equals 3 minus b ln 2 plus b ln 5. Okay. And this is where, we have calculators to help us, but we can start solving this. We're trying to solve for b here. So I'm going to subtract the 3 just to get it out of there. And I have minus b ln of 2 plus b ln of 5. And this is why doing this by hand is a little bit more work than just doing the regression. You have to understand, oh, there's a b in both of these things, so I can pull a b out. and you get this. Okay, equals 4, and we're trying to solve for b, so I'm just going to divide by this. So you'll notice I haven't actually touched any calculator yet. It's just been equation manipulation. It's a very good skill to have on the AP test because they love to ask you to manipulate things. But Calc OK means I'm going to type this now on my calculator, and you're going to get that b is roughly let me just look at what it was because I don't have my calculator with me on my computer right now. So 4.365. I think it was 4 and then ... So we're going to round it to 3 decimal spots to 4.365. Okay. And then you get to do the same thing, or now you get to substitute this in, because you should always use the exact one, in for B in the equation that you solve for A. So again, this is what I would have if I was doing this all by hand, which is really long, times the natural log of 2 equals A. Type this whole thing in the calculator, and you'd end up getting that A is negative 0.02588, ... Again, we're going to round to 3 decimal spots, so 0.026. And there's our A, there's our B. Okay. I would have done it with regression, would have been much quicker, but I wanted to show you the long way so that way you can appreciate the regression. All right. Well, thanks for watching and have a good day.